Let's look at the concepts of real limits in this chapter 2, problem number 7. When we have a number written down, what does that really mean? We can't be as precise as we like. We can't be exactly precise and measure things exactly just as God sees them. So we have to use kind of limited means of measures. So when we write down a number like 2.7, it really might be something like 2.69 or 2.71, but the limit to how close we can get is limited, so we'll just say it's 2.7. Now in this example, we have a number of measures that are given to us, and we are supposed to identify the real limits. It says, determine the real limits of the following values, and it gives us 5 different values. What we're going to do is we're going to put this in a table. Let's label the first column value, the second one units, the third lower real limit. That's how low it can actually be and still be recorded as that number. And then the other one, last column, is going to be upper real limit. And that's how the maximum an actual value can be and still be recorded as that unit. So let's make these columns bigger so that we can read them. And the first one is 10 pounds. So we'll put 10 as the value. The unit is pound, LB is the abbreviation for it. And that means that can go from 9.5, which we would round up to 10, all the way up to 9.4999999, which will or 10.49999, which we'll write as 10.5. Now, if we actually measured something that was 10.5, we'd record that as 11, but instead of writing 10.4999999 almost forever, we're just going to put in 10.5. So that'll be the upper real limit. B says 2.5 seconds. So the abbreviation for second is S. The lower real limit is 2.45, because that would be rounded up to 2.5. 2.44 would be rounded down to 2.45. And the upper limit would be half of a tenth of a second above it, 2.55. Anything up to 2.55 would be rounded down to 2.5. The third one is 100 grams, and it says assume that we can measure it to the nearest 10 grams. So we can measure 110 grams or 120 grams, but we can't measure 111 grams. So our value is 100 grams, and the unit is G, grams, and so that goes from 95, that would be rounded up to 100, because we can't measure 95, 96, 97. We can only measure to the nearest 10 grams. And this goes to a maximum of 105 grams. Now the next one is 2.01 centimeters, cm. And so that would go from 2.0 and then whatever would get rounded up to 2.01. So that would be 2.005, because that would get rounded up to the next highest digit, and anything below 2.015 would be rounded down to 2.01. So we got to be really careful with the decimal points, because we can measure to the nearest hundredth of a centimeter, but so we have to look at what would be the thousandths of the centimeter on how things would be rounded. The next one is 5.232 seconds. So that's S once again. And here we've got to go to the fourth decimal point. So this anything above 5.2315 would be rounded up to 2.32. And anything below 5.232, and we can go all the way up to 5, would be rounded down to 5.232. Now let's put this table insert a table here so it looks nice. So I went to the Insert tab. I'm going to click on Table, and it says my table has headers, and this is the limit of the table. I say OK, and here we have a nice data table showing what the real limits are for these different values that we've measured.